So this is question 13 of the 2014 paper for OCR Gateway P6. So the first thing we've got here is we've got a voltage current graph for 5 different ohmic conductors. You can tell because they're straight lines, so they must be ohmic, constant resistance. Calculate the resistance of conductor B. So we know first of all that voltage is current times resistance. That's something it's on the data sheet, but you should actually also know that. Some of you may know it as the triangle. I personally don't like using the triangle, but a lot of people do, so I recognise that. So you want to know the resistance, so you cover up R and it's V over I, or you can just rearrange it and you end up with the idea that resistance is the voltage divided by the current. So then you want to look it up on the graph. So it's a straight line, you can measure it pretty much anywhere, so let's just pick the most convenient point, which is 6. So your voltage is 6 volts. The current is 0.8 amps. That's fairly easy. So if that's V equals IR, V is voltage, that's 6 divided by 0.8, which is 7.5 ohms. Pop your answer in the right place there. Next one says all ohmic conductors are made from the same material. They have the same cross-sectional area. They're all different lengths. Use the graph to write down the letter of the conductor with the longest length. So the longest length is going to be the highest resistance. So it makes sense that long length means high resistance. Probably not the best way to put it, but it'll do nicely. Means a high resistance, okay? So on this graph, the highest resistance would have the smallest current for the corresponding voltage. So this would be the shallowest E. So a high resistance you can use a nice little symbol if you like. It means implies a shallow gradient or shallow graph even. Shallow gradient. So the one with the shallowest gradient is E. Now the examiner will not give you any marks if you don't get that bit right, okay? But they won't give you any marks for that bit either. They give you the marks for the 2 parts of the explanation. One idea, recognising that if you've got a long conductor, it's going to have a high resistance. And second mark for then recognising that a high resistance on the graph would be shown as a shallow gradient. On to part C, George investigates the metal filament light. George tries to explain how the resistance changes, so he writes that current in a conductor is the flow of charge carriers called protons. The charge carriers collide with the atoms in the conductor. This makes the atoms vibrate less, which causes an increase in collisions, decreasing the resistance, and increases the temperature of the conductor. So he's made 3 mistakes in his model, so state the 3 mistakes and write down the corrections. So the first mistake he's made, well, first of all, it's not protons, it's electrons, okay? So 1... the idea should be that protons is the mistake, and it should be the idea that electrons are the charge carriers. Okay, that's the first one. Second mistake, the charge carriers collide with the atoms or ions in the conductor. That's correct. This makes the atoms vibrate less. No, they vibrate more. So that's your second mistake. So we say that when electrons collide with ions, the atoms or ions collide, vibrate more. Okay, and the last one, where it says this causes an increase in collisions, decreasing the resistance. That bit is wrong. It doesn't decrease the resistance, it increases the resistance, okay? So, more collisions increases resistance. And just to make it really clear to the examiner, I'm showing underlining the bits where you actually should put in the keyword. Okay, and that is then a well answered question. So basically, if you correct all 3 mistakes, the examiner would give you 2 marks. If you corrected, say, 1 or 2 of them, you'd only get 1 mark.